So let's just dive right in, because something huge is happening in the world of AI right now. And I mean huge. We're talking about a fundamental shift, kind of like the moment alchemy finally turned into modern chemistry. This is the story of how artificial intelligence just got its very own periodic table.
You know, for the longest time, if you were an AI engineer, your job was, well, a little bit like being a magician. You'd take these gigantic piles of data, you'd mix them with just a ridiculous amount of computing power, and you'd kind of cross your fingers and hope that what came out the other side was gold. And sometimes it was. But the crazy part is you couldn't always explain the scientific reason why it worked.
And that really gets to the heart of what's changing. We are moving away from this era of AI as alchemy, which was all about guesswork, secret family recipes, and totally unpredictable results. And we're stepping into the world of AI as chemistry, a world that's built on solid first principles, on universal laws, and on getting results you can actually predict and repeat. This isn't just a small tweak, it's a complete reimagining of the entire field.
All right, so let's dig into that. What exactly was this alchemy problem that everyone was dealing with?
Well, for decades, the AI world was basically like a giant workshop with tons of different separate toolboxes. If you wanted an AI to recognize faces, for example, you had to use this very specific set of spells from computer vision. But if you wanted it to write a poem, nope, you needed a totally different spell book for natural language. There just was no grand unifying theory of everything. It was all super specialized, and researchers were just kind of hoping their particular brew would be the one that worked.
But then, recently, some researchers started asking a really powerful question.
What if all these different kinds of magic weren't actually different at all? I mean, what if recognizing a dog in a photo and understanding the word dog in a sentence, what if deep down they were both just slight variations of the exact same fundamental principle? And this is the breakthrough. This is it. Researchers from MIT and Google have put together a framework that is, for all intents and purposes, a periodic table for AI. It takes all these different methods that we thought were completely unrelated, things for grouping data or for connecting images to words, and it lays them all out and shows, whoa, they're all connected. It reveals this hidden order in all the chaos, proving they all play by the same basic rules.
Probably the easiest way to wrap your head around it is to think about cooking. For years, we thought building an AI that can see and building one that can write were as different as baking a cake versus making a stew. Totally different recipes. But this new framework proves that's not true at all. It's all coming from the same master recipe. The basic steps are the same. You just tweak the settings a little bit. Okay, so what is this master recipe? What's the secret sauce? Well, here's the wild part. It isn't about remembering more. It's about the art of forgetting.
The science behind all this is a concept from researchers at Emory University called the information bottleneck. And the main idea is pretty simple. The smartest, most effective AIs aren't the ones that try to memorize every single pixel in a photo or every single letter in a book. No, the best ones are absolutely brilliant at throwing away all the useless noise, the color of the wall in the background, the irrelevant words, so they can focus on the one true signal that actually matters.
You can think of it like this. When you squint your eyes to see something far away, what are you actually doing? You're blocking out all the extra, distracting light so you can just focus on the essential shape of the thing you're looking at. Well, that's exactly what these advanced AI models are doing with data. It's like they're squinting, but computationally. And one of the researchers, Michael Martini, he put it perfectly. He said this new understanding basically gives them a control knob. So now, for any problem, they can just dial in the exact amount of information the AI should forget and how much it should focus on. No more guesswork, no more just throwing stuff at the wall and hoping it sticks.
But look, just organizing the stuff we already know, that's amazing. But it's only half the story. The most exciting part of any periodic table isn't what's already on it, it's the blank spaces.
Let's go back to high school chemistry for a second. Remember Mendeleev and the periodic table of elements? The absolute genius of that thing wasn't just that it organized all the elements we knew about, it was the gaps he left. He created blank spots that actually predicted the existence of elements, like gallium, years and years before anyone ever found them. He didn't just make a list, he drew a map to the future.
And that is exactly why this moment in AI is so thrilling. This new framework, this table, it's also a map, and it has blank spots. It's pointing toward entirely new kinds of AI that are theoretically possible, but that nobody has even thought to build yet.
So what kind of new AI elements could we discover in those blank spots? We're talking about super focused tools built from these new rules. AI is designed specifically to create personalized medicine, or to discover new materials we could use for batteries, or to build way more accurate climate models, or even to help automate the process of scientific discovery itself.
Okay, so this is all really fascinating, I get it, but what does it actually mean for us in the real world? Why should we care that AI is moving from being alchemy to being chemistry? Well, it really boils down to this one simple idea. When you're exploring some new, unknown land, having a map makes the whole journey cheaper, faster, and a whole lot safer. And this periodic table, it's the first real map we've ever had for the world of AI.
So first up, cheaper. The old alchemy method wasted an unbelievable amount of energy and data on just trial and error. By being able to design AI from these core principles, we can make them way more efficient. And that means they'll need less computing power, which is good for the wallet and, frankly, a lot better for the environment.
Second, faster. This is going to accelerate innovation like crazy. Instead of spending years randomly trying different things, scientists can now go right to the map, find the right principles they need, and start building the right tool for the job right from the get-go.
And maybe most importantly of all, safer. Let's be honest, a huge fear with AI is that we don't always understand why it makes the decisions it makes. That leads to errors, to biases, to those weird hallucinations. But once you understand the fundamental chemistry of a system, you can start to make it more predictable, more reliable, and ultimately, more trustworthy.
This is a landmark moment. For the first time, we're not just users of some mysterious AI magic, we're actually beginning to understand the science behind the spells. We finally have a map to this new world of intelligence. And so the only question left to ask is, where do we go first?